this section, we'll be looking at the graphs of quadratic functions to get better acquainted with some of their properties. We will start by graphing the most basic of the quadratic functions. Since we can square any number, the domain is all real numbers. As for the range, we will need to collect some more information from the graph in order to state the range. It will not be all real numbers. The domain for all quadratic functions is all real numbers. I am putting in a fairly small set of integer values. The function says to square for the output. What we notice is the range is 0 and all positive values. This is due to us needing to square the input values. Let's use this first graph to state some properties of the graph. All quadratic functions have the same basic shape, a U-shaped graph. We refer to this shape as a parabola. There is symmetry with all the parabolas. You will be able to draw a line down the middle of every parabola, and you will see a mirror image across this line. This imaginary line we draw is called the axis of symmetry. This line of symmetry will always go down through the lowest or the highest point that we will call the vertex. Let's first focus on the leading coefficient of the quadratic function. Changing A will change how the parabola opens or the width of the graph. The sign of the leading coefficient determines how the parabola opens. If the leading coefficient is positive, the parabola always opens up. If the leading coefficient is negative, the parabola always opens down. The magnitude or number part of the leading coefficient determines the width. If A is greater than 1 and is allowed to get larger, the parabola will get narrower and narrower. If A is less than 1 and allowed to get smaller, the parabola gets wider. For the graph of f of x equals x squared, the vertex is at the origin and the axis of symmetry is the y-axis. Let's take a look at what happens to the graph when a value is either added or subtracted from x squared. What we notice is that if we add a constant value, there is a vertical shift up that number of units. If a value is subtracted, then there is a vertical shift down that number of units. Let's take a look at when we see a horizontal shift. With a horizontal shift, a number will be bound to x with parentheses. Here's how most students interpret this. By the way, you will see the horizontal shift opposite in terms of the sign of what we saw for the vertical shift. For the first graph, the function is x plus 4 squared. Most students will take that number opposite that sign for the horizontal shift. So for x plus 4 squared, I would see a shift of 4 units left, since the horizontal shift shows up opposite of what we'd assume it to be. As for the function equal to x minus 2 squared, the shift would be 2 to the right. Again, thinking opposite of the sign of what we see in that binomial. For our last few slides, let's look at functions with more than one transformation. Since the leading coefficient of this function is 1, it shares the same width as x squared. But what we will see is that the function y equals x squared will get shifted 5 to the left and 6 down. Therefore, the vertex is moved from the origin to negative 5, 6. The second function will open down and will be narrower than y equals x squared with a leading coefficient greater than 1. It will get shifted 4 to the right and 2 down. As you can see, the vertex completely corresponds to the horizontal and the vertical shifts. The axis of symmetry will always go down through the middle of the function, passing through the vertex. Because of this, the axis of symmetry, being a vertical line, will share the x coordinate of the vertex. Hopefully this has been helpful. Thank you for listening.